The Hilina Slump. I've been thinking about making a video on this topic for a while now, since all this volcanic activity started in Hawaii, but it just hasn't been, I guess, a big enough topic in the public forum to really inspire me to make a video. But I have been asked recently a couple times about it, so I thought I would go ahead and create a video and help people understand what this Hilina Slump is all about and what's going on with the volcanic activity in Hawaii, just for some context. And so this is something that I've looked into because I do watch what's going on with volcanoes and earthquakes and things like that, and this certainly qualifies as a part of that subject area. So it is incredible. First of all, it is, I would go so far as to say, unprecedented, and you have to qualify that. So instead of just meaning, has there been a lava flow that's gone longer than this? We're approaching 90 days, I guess, at this point. And the answer is yes, of course, much longer than this. So it's not the length or the duration of the flow. It is the volume consistently since the beginning to now, the fact that it's not slowing down, and the speed of the lava flow. Hawaii is usually, and generally speaking, they're what's called shield volcanoes, which are kind of lower volcanoes altitude-wise, and these volcanoes erupt very slow, if you remember the videos from the beginning of the Hawaii situation, slow-moving lava that just kind of creeps along and so forth. So while it can show up in neighborhoods and be very damaging, it's not a really huge event. And there's some exceptions to that. If you want to look up the the Hawaiian fire hose, which is it's a part, I believe it's Kilauea, that erupted, and it was just pumping. It looked like a fire hose punching lava out into the ocean, but it was just one little hose, just pushing lava out in the ocean at a pretty good rate. So and that went on for quite a while, but and there's all kinds of pictures on the internet if you want to look that up. But this is unprecedented in its volume and its scope, and because I think that we've got a new volcano forming, meaning that this fissure 8 is now over like 200 feet tall and growing. And scientists, even after this much time, are saying there is no end in sight. So it looks like the actual volcano Kilauea, which was active with an active lava lake. The lava lake has completely retreated. The volcano caldera has been collapsing in on itself. It looks like it's kind of sealing up there. And the new active part of Kilauea is going to become Fissure 8, sort of a new volcano that's going to be bubbling up and over and so forth, right? And we'll talk more about that in a minute, but I want to focus on the Hilina Slump, or Hilina Slump, and what that is. So this is the area of Hawaii that we're talking about. It's small relative to the size of the island. Kilauea is right in here, the actual volcano, and then over here we've got right in this area Mauna Loa, which is the big volcano on the island, much bigger than Kilauea. Okay, just not as active. It is an active volcano, but not as active. Okay, there's your context. Now, what is the Hilina Slump? Hilina Slump. Here's a quick picture, just again, Google Images. Here's the rift zone. There's Kilauea. So in the distant past, Kilauea erupted. And think of it like the East Rift Zone here and the Southwest Rift Zone used to be the coastline of this Hawaiian island. And the volcano filled it in and created this entire area. Okay, and you can see the yellow area is where there's a lot of cracks, fault lines, things like that make it fragile. But the whole area from the rift zone out to the coast is a danger zone because it's called a slump. It means it's It's not a part. If you've ever poured like a concrete slab, and then after it dries, you come and pour, more concrete slab. They never quite, they do bond, but they don't quite fit together, and they're likely to crack. And that's what we've got going on here. Also, it's important to point out, let's go to Google Maps, topography. Okay, there's the big island. And you can see this appears more typical, volcanic islands, ancient volcanic islands. And you see how shallow the water is around the island. It gives you these beautiful blue, rich, bright, light blue waters and so forth, and excellent fishing and all that kind of stuff right off these Hawaiian islands. Absolutely gorgeous. Then we come down here, and you notice the drop-off. Okay, so a couple things to point out here. You can see kind of, I don't know, I'm going to refer to it as a mountain ridge that comes up here and hits the island, and you can see the slump. This is the rift zone, right? So it comes up here to the volcano, and then it comes back out like this, right in there somewhere. Okay, so this area is the Hilina Slump. The area of concern is more this, from the point here over to about here, because if I zoom in, it's kind of hanging over the cliff, right? There's the ridge of the mountain, and this is just sort of sitting there off the edge. Okay, so you get kind of a good feel now, I hope, for the risk of this. Now, and there's been a significant movement in this slump in recent years, but nothing that was unexpected or predicted. Okay, so it just it's moving. All right, but here's a couple things you may not have known about, or maybe worth noting. First thing I'm going to point out is this right here. This is another volcano. Many scientists believe that, and it is an active volcano, lightly active. There have been a lot of signs that it has erupted in the recent past, but not everyone agrees with that. So I'm just going to leave that at it. It's an active volcano under the water, and so we don't have like direct monitoring of it. But there's a lot of scientists that say that this volcano actually shares a magma chamber with Kilauea. So if this one's active, well, you can bet this one's also doing something, right? So so there's that volcano off the coast, and that's responsible for this whole geography, kind of shallow area here. Now, notice this. This is on the bottom of the abyss, right? It drops pretty straight off from the coast, and you got this. All right, this is another slump, and scientists have gone down and studied this. It's very, very, very deep, and what they've concluded, or at least the prevailing theory at this point, is that this used to be a part of the island as well, and it fell off the cliff and sank to the bottom of the ocean. And of course, they've done all their surveys around the world and found that there probably was a massive tidal wave that rippled in the southern hemisphere and so forth, and created a tidal wave that caused some disasters, right? So this is past. This is present slump, and you can almost see the line, right, where it comes across. And of course, the fissures that have been happening are out here. There's Poa and Lilania Estates. We'll look at that in a moment, or over here, and so forth. Okay, so this is the area. Now, there's been tons and tons and tons of new weight, new rock bubbling up and running all off the side of the island. So an extensive amount of weight. The fissure or the fault line here, the rift, has been perforated with all these fissures, and so there's some concern about that. Now, what happens if this does fall off to the bottom of the ocean? Two things. First is a massive earthquake. So we're talking like historically, potentially one of the largest earthquakes ever recorded. It would be a 9-point something is what's expected if that were to happen, and this whole piece of land could just tumble right to the bottom of the ocean, very deep ocean. So it'd be a massive, massive tidal wave or tsunami that would come from this. And if we back up, in fact, I think I've got another picture here to show here. All right, so yeah, so this just kind of shows there's our ridge line, there's the slump, and they're talking about a tidal wave coming off the island like this. Okay, if we go back to our Google Images and scroll up, we'll pick this one. All right, you can see there's the island, and this is what we're looking at. And these are just predictions. In fact, I've seen some predictions suggesting that it would be a larger tidal wave. I don't know. But, 60 feet and then coming down to 30 to 40 feet by the time it hits the west coast United States and the northern end of Mexico. Okay, and then dwindling, but still a tidal wave as you get down to South America. Okay, so, yeah, so there's that. Right, if this happens, it could be quite bad for the United States. I'll take this one notch further. If you look at seismic activity and volcanic activity, you see a lot in South America. You see a fair amount in Central America, and of course we've got volcanoes and earthquakes happening in Mexico, right? But not a lot going on in the United States. And then we've got a lot of activity up in Alaska, the Aleutian Islands, and so forth. So Canada, the United States, we've got the San Andreas Fault, which you probably heard about down in California, and that's inland. And then all of a sudden it breaks, and there is another fault off the coast that creates what they call the Cascadia Subduction Zone, or the Juan del Fuca tectonic plate. It's a little plate out here. And scientists have said it's under extreme pressure. And also scientists have said that if that cuts loose, the way things are right now, we would be looking at a 9-point-something earthquake and a massive tidal wave rolling into the United States. So let's go back to Hawaii. The thinking is that it would be potential. All right, and this is like real speculation because scientists really don't know about this kind of thing. But you're in the middle of the Pacific Plate here, the tectonic plate, right? And you've got a 9-point-something, over 9.0 earthquake that happens here, and a massive tidal wave. That earthquake is going to shake all the way to the edge of the Pacific Plate, and where it's under extreme pressure, it could cause a kind of a domino action, right? So it would release or vibrate to the point that the Cascadia Subduction Zone or San Andreas Fault would break free and cause a huge earthquake, potentially a second tsunami of even larger size, washing in minutes onto the higher Oregon, Washington State, Vancouver Island, this area up here. It would come washing in over the United States in minutes, right? A couple minutes it'd be there. That would be bad, all right? And I'm getting out there now. So let's just stop there and say that this is why scientists are very concerned or interested in watching this Hilina Slump very, very, very closely, all right? Because of the potential for something other than just a 30-foot tidal wave, which would be bad enough and reason enough to watch the slump washing up in the United States west coast. Okay, so there. Now you know the Hilina Slump. That's what that is. Hilina Slump. Sorry, I keep saying that wrong. But all right, so that's what's going on there. Let's take a little look at this rift zone, just to give you some insight while I'm on the topic. I'm not going to dwell on this going forward, but so you can see what's going on. The green triangles represent the faults or the rifts, the fissures, that have popped up. A lot of them, right? They started here, this blue, this is the Lilani Estates. There you go. Not tagged very clearly, but that's it. So all these blue lines and green lines represent the roads with a bunch of homes. And let's see, fissure 1 here. And then all of a sudden 2 opened up here, and there's 3, 4, and so forth, right? So all these fissures started popping up right along the rift zone. So right on the trigger point for the slump, where worst case scenario would start to move, right? So this area, let that populate, is in direct alignment with the volcano, right? So, so what we have here is a situation where lava kind of shot off horizontally along the rift zone and came out here and started popping up and bubbling up with lava. The orange represents the lava that's flowed in this event. The darker and lighter gray areas represent ancient flows that we know about. So don't worry about that so much. The orange is what we're really looking at. Another thing that's interesting here, and this, of course, was a big popular area over here. Some very expensive homes down here and so forth. And if I go in and turn off, let me move this over a little bit. Okay, I'm going to turn off the lava flow outline. All right. So there's Kapoho Bay. Very, 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 I guess, big tourist area. I'll just leave it there. And all this over here, right? So now let me turn on the lava flow. Now watch the land. Okay? See? Hawaii got bigger. In fact, at this point, it's over 400 acres larger off this cliff, right? So the ridge line comes in up here. And so all this is new land hanging off the cliff into the abyss on this southeast part of the island. All right. So more reason for risk, more reason for concern about this Hilina Slump, and so forth. Of course, all of this is additional weight. You know, hundreds and hundreds and hundreds of tons of rock is now weighting down this part of this slump that was not there weeks ago. The slump moved as much as 2 feet in the past year, so it is sliding down. So we've got an actively sliding slump with hundreds of tons of new rock, weight on top of it, and more weight hanging off the edge, over 400 acres of new land created off the cliff. So you get the idea, right? We have a potential for a bad situation, one way or another, that although it's way out in the middle of the Pacific Ocean, could easily have a very direct impact right here in the United States. Okay, so in a really, really kind of a negative way. Last thing I want to point out, because you know in the news you see a lot about this thing that they call the Puna Geothermal power station, right? And it is kind of intriguing. There's some conspiracy theories out there and things like that about it. Well, let's take a look at it, and then you be the judge. But the residents of Hawaii have been concerned about this plant. First thing to point out, and this will be the last thing I touch on, is that what is a geothermal power plant? Well, it's where they drill down deep into the earth, where the mantle, the hot part of Earth, is warming the crust so much that you can either pump water down and pull that water back up, or pump water in, and then anyway you pump water in, and what you get out is pressurized, extremely hot water that can then be used to turn like steam turbines and things like that and generate a pretty reasonable amount of power. Now, geothermal plants have not been terribly successful, and there's only a couple that are really proven successful in the world. All right. So the first kind of question that jumps out at you is, does it seem like a good idea, let's just put it that way, to put a geothermal plant where you drill into the earth and perforate it, so to speak, right on a rift zone on the edge of an active volcano? It's a reasonable question. Certainly, if you live here, is that a good idea? Right in a residential zone, by the way. It's not like they're way out in a remote part of the island where if something happens, it happens to the plant. It's just right in one of the hottest residential zones on this part of the island, right? The plant is right in here. Okay, in fact, I can show you. You see, this is a road, the blue line, and you see how it curves right there? Okay, it takes that dip. All right, let's go back to Google Maps. And if I zoom in over here, States, I'm going to leave in satellite view. All the homes in here now gone. Here is where the road comes down and ends, like we saw on that other map, right? Right there is the geothermal plant. All right, so you get the location right there. Let's go back over here. It's right there. So they put it right where the lava destroyed a bunch of homes, but worked right around, miracle of God, the geothermal plant itself. Now, it did cover a little bit of the field, the geothermal field that's out there, some of the holes they drilled, in other words. But in general, the plant is unscathed, the primary components of the plant and so forth. So that's just kind of interesting. Also, it's interesting that out of the entire rift zone, we'll let this populate again, right? The rift zone goes all the way to the edge and all the way back to the volcano. And right in the middle of all these rifts, almost dead center, is the geothermal plant. That's ironic, right? Anyway, I'm not going to dwell on that, but it's just kind of interesting that geothermal plant is right there. It's in the news, so I thought I'd mention it. I'm not making any, I'm not trying to say that there's some kind of nefarious activity going on at that plant, but it does make you wonder, why would you do that in such an active volcanic region, drilling holes in the earth to get hot water? Certainly you wouldn't have to drill far to get hot water, so that's kind of good. But is it a good idea in a residential area to drop something like this? And then there's just the coincidence, that the center point, sort of all this activity with the rift is right where they're drilling perforation holes in the earth on a rift zone, on the edge of a slump that's causing a lot of concern because of the impact of if it falls off the island. So there's a lot of things that make you just kind of scratch your head about what the heck were they thinking, putting that there. And this is something that if you ask the folks that live on the island, they'll say they've been scratching their heads and asking these questions for a long, long time since they put the thing in. So there's that. All right. So now you know everything that I guess I know about. Not that I'm an expert again, but what's going on in Hawaii with Kilauea and the lava flows. We've got the impact of the Hilina Slump and the potential that it might eventually actually slide off into the ocean. We've got the massive amount of weight, the residential devastation, the geothermal plant, and so forth that's going on out there. There's a lot going on. And again, in my opinion, it is unprecedented. This is very, very unique. It'll be interesting to see how long this continues at this rate of flow and this speed of flow. Extremely hot magma flowing like a river. So it's an interesting topic. I hope this was in some way either interesting or helpful to you. Have a great day.